4.7 is about inverse trig functions. We have 3 of these. We have them for sine, cosine, tangent. We don't have them for the cofunctions because it's kind of redundant. There's really no need for them. So here they are. And we'll talk about why they're used in just a minute. But you'll see it written these 2 different ways. You can see it. It's said arc sine, arc cosine, arc tangent, written like an inverse. And that's appropriate because it really is an inverse, and you're going to see that in just a moment. That notation with the -1, like an exponent, it's not an exponent, but it stands for inverse of the sine function. So that's the overall notation you're going to be seeing. You'll see both of these used. I know Desmos, if you type in arc sine, then it automatically knows to do this. Your calculator, it'll have this notation if you try to put something in it. The reason for these is to help us work kind of backwards and find an angle. So something I stated back a few sections ago, and I actually used this example. I said, all right, well, if we have sine of a 30-degree angle, then this side's always half of the hypotenuse. And it's a ratio. No matter how big that triangle is, if there's a 30-degree angle here, this piece is half of the hypotenuse. So it's really just working backwards from that. If you have the ratio, if you know the ratio, you can kind of work backwards and find the angle that has to be between the 2 lines. So that's where we'll start with this. Sine of x is 1/2, something right off the unit circle that we could answer without even probably doing any work. So x could be 30 degrees, or it should be 30 degrees. So here's the other thing. Think about this. X could be, well, the other place where that would be true is at 150 degrees. Of course, we could get into radians, but I'll keep it simple for now. So this brings up a point that we're going to get to soon. There's really only one answer. If you actually take arc sine to solve this, there's only one answer. You can check a calculator and see that. So this is a big part of it. We have to settle on what the answer is if we're going to call this a function. Because that's what a function's all about. You put something in, you've got to get one thing out. You can't get multiple outcomes. That's what the vertical line test is about. If I put in a number for x, it's got to lead to one result for y. So let's look at how we can conclude this and how to do it algebraically. So sine is a function. You're taking the sine of an angle to get a result. To undo a function, you have to do an inverse function. This is something that you'll start to see more and more as you go through higher levels of math. So we can do that. We can take the inverse function as long as we do it to both sides. And for the sake of this one, you can kind of think of those as canceling out. The inverse function undoes the original function, so that all you're left with is x. This is where that composition idea comes in, because these are inverses. And if you compose an original function into its inverse, the result was just x. Right? That was something we talked about with composition. So that's how we know that has to work out. And in your calculator, you can do it for now. We won't continually rely on the calculator, but for now you can type that in, and you will get 30 degrees out. Or if you're in radians, you'll get pi/6 out. But you only get one answer because it is a function. All right, so we've got to kind of settle that idea, and we will soon, about, well, wait a minute, if I graph this thing, it could be 30, it could be 150. Both of those fit the case, a unit circle. So we're going to answer that question, but this is the result you will get. X equals 30 degrees. And this one's going to be doing some algebra as well, but you're not going to get a concrete answer out this time. It's more of just kind of rewriting how this would lay out. So find theta in terms of x. In other words, solve for theta. Well, if theta is right here, and I've got a hypotenuse and an adjacent side, then cosine is what's going to make sense. So cosine of that angle is x/25. And if I go to solve this thing for theta, then I need to take an arc cosine, or inverse cosine. And again, by that function composition rule, that becomes just theta. So theta solved is arc cosine of x/25. And hopefully that kind of makes sense, because depending on how long x is compared to a length of 25 here, it's going to really change how big this angle is. I mean, to make the triangle work out, it's going to change things around. So the length of x right here is going to determine what the angle has to be. So let's take a look at the graphs and let's try to answer that question about how do we settle in on whether that was sine of 1/2 is 30 or 150. So let's settle in on that. So it is an inverse. These are the inverse trig functions. And to graph an inverse, I'm just kind of starting out with a little review, switch the x and the y. That's really the key to an inverse. You switch the x and the y values and that becomes the inverse of the original function. So let's take a look at what sine looks like. At 0, it's 0. At, I'll do one cycle this way. So at pi over 2, we're at 1. Pi back to 0. 3 pi over 2 back to -1. Back to 0 at 2 pi. And because I kind of know where this is going, I'm going to go back the other way as well. I'm just going to go that far. So this would be negative pi over 2, negative pi over, this would be negative pi, this would be negative pi over 2. And that's really all I need to get the arc function. Now, let's throw something else back there we looked at earlier in the year. Does this pass horizontal line test? Because I'm talking about inverses here. So if this fails horizontal line test, my inverse is not going to be a function. And that's what we got going on. It's definitely not going to pass horizontal line test. So that means we got to trim this thing down a little bit. We have to restrict the domain so that it passes the horizontal line test. Ultimately, the inverse will be a function. So what I'm going to do, I'm just going to kind of take this as is and translate it over here. And hopefully, pretty clearly, you can see that it's not going to pass vertical line test. And then we'll talk about trimming it down. All right, well, let's see. We got 0, 0. Now, the angles will become the the angles will be on the y-axis now, and the 1 and -1 will be on the x-axis now, because in an inverse, we switch the x and y. So let's get a few. Let me go up to pi, and let me go to negative pi down here. So pi over 2, positive pi over 2. We can fill in some other stuff if we need to. All right, so let's put some points on. 0, 0 is on there. Pi over 2 is going to be a 1. Pi is back to 0. Negative pi over 2 is at -1. Negative pi is back to 0. So for now, I'm going to just kind of fill this in. But it's not going to pass vertical line test. So we got to settle in on where are we going to cut this thing off. And we need a standard that we can all agree to. That's really the only reason that the interval you're going to see is the true interval for the function. All answers you put in the calculator are going to be between this angle and this angle. And we'll talk about what that is in a second. But we just need a standard that we can all agree to. That's really what it comes down to here. So the standard that we try to go by is if we can include 0 in this section, we're going to do that. So if you want to cut this thing off in a way that it would pass vertical line test and include 0, 0, the thing that makes the most sense is to cut it off right here with pi over 2. And then once it starts to kind of backtrack on itself here, cut it off down there at negative pi over 2. So your arc sine function will only go from negative pi over 2 to positive pi over 2. Now let's go back to that question about arc sine of 1/2. We said the answer was pi over 6 or 30 degrees. Well, by the logic here, we could have also gotten 1/2 at 5 pi over 6 or 150 degrees, but then we're getting multiple. There's no limit to how many answers you could get out. There's an infinite number of answers you could get. And if we're going to make this a function, which means we get one answer out for our x value, we've got to cut this thing off, and pi over 6 would be the only answer you get for 1/2. So arc sine of 1/2 would be pi over 6. So that's what we're going to cut it off. We're going to go from negative pi over 2 to positive pi over 2. And that will be our graph. That's it, just from there to there. All right, we'll start with the regular cosine. We'll start with 1 and -1. 0, 1's on there. Pi over 2, you're back to 0. By pi, you're down to -1. And I'm going to just kind of do a cycle this way. Actually, I'll go one more. I'll go up to here. I won't even label that because it's not going to pass horizontal line test. We've got no problem there. All right, so negative pi over 2 goes back down, back to 0 at pi. And then I'll go back up a little bit more, but we're really not going to need that. So if we're kind of looking ahead, same rules. How can I include 0 for the x value here and cut this thing off so it passes horizontal line test. Well, we can't really take this same interval we used for sine, because it's not going to pass horizontal line test. So the intervals that make the most sense are from negative pi to 0, because it would pass horizontal line test there, or from 0 to positive pi. And I think given those two choices, I think probably all of us would pick the positive version if we could. So that's the standard we're going to go by. You're going to cut it off from 0 to pi radians. That's what I'll put over here. I'll go from 0 to pi radians, put pi over 2 in the middle there, and 1 to negative 1 for your x values now. So if your x value is 0, you're at 1 for y, switch those, so 1, 0. All right, at pi over 2, you're at 0, so 0 pi over 2. And at pi, you're negative 1, so switch those, negative 1 pi now. And this is basically what your arc cosine graph is going to look like. For tangent, let's start with those asymptotes. So negative pi over 2, positive pi over 2. At 0, we're at 0. At pi over 4, we are at 1. And at negative pi over 4, we are at negative 1. Let's get some of those points on there. So, here, 0, 1. Fill that in. Kind of does this shape. All right, so now let's translate that over here. Well, as far as horizontal line test goes, as long as we're inside of these asymptotes, we're good. So really, these asymptotes just get translated to the y-axis over here, negative pi over 2 and positive pi over 2. Now, if we included one more section either side here, we would fail a horizontal line test, and then you can kind of picture how you have these sideways kind of wave things going on here. So we can only, negative pi over 2 to positive pi over 2 is the only thing that really makes sense. Same thing as sine. It's the same interval sine exists on. And let's just move a couple points. So 0, 0 will be on that. We're at 1 and negative 1 at pi over 4 and negative pi over 4. So negative pi over 4, negative 1. And on the inverse part, 1 pi over 4. And it just kind of does this shape. It's kind of a sideways x cubed function, I suppose you could say. It has horizontal asymptotes, that's the key. And there's no limit to how far you can go on the x-axis, so that's maybe a little bit different from the others. Definitely limited on what y values we'll get out, but you could put any x value in here and it would show up somewhere on that graph. All right, so as we go through these next few examples, if you start to feel like there's got to be a catch, you're right, there is. So at first it's going to look like it's going one way, and then it's going to kind of go off in a different direction, and then we'll explain why it did that. So let's kind of do a few of these inverse of the original function and see what happens. Now, again, function composition says if we take the inverse of the original, they nullify, and we end up with what's left right there. There's a little bit of a catch with these arcsine functions because of the domain restriction, so keep that in mind. So we've got arcsine of sine of pi over 3. So let's just, as always, begin on the inside. All right, so sine of pi over 3. Okay, pi over 3, that's up here, so square root of 3 over 2. Should be pretty quick at recalling that. So now I'm finding the arcsine of square root of 3 over 2. All right, well, arcsine's got to be from negative pi over 2 to positive pi over 2. So just kind of think backwards. At what angle, and I start in radians, so let's stay in radians. At what angle between negative pi over 2 and positive pi over 2 is my sine ratio square root of 3 over 2? And that's going to be pi over 3. Okay, so it did feel like it was as simple as just cross that out. All right, tangent of arctangent, square root of 3 over 3. All right, so now we'll kind of start in that other spot. Arctangent of square root of 3 over 3, well, arctangent also from negative pi over 2 to positive pi over 2. We need to make sure we know that. So that's the name of the game. Give me an angle between negative pi over 2 and positive pi over 2 that the ratio would be square root of 3 over 3. And if it's not given in radians or asked to be in radians, you can put degrees here. That's okay. Radians is kind of the default, but I'll put degrees here because that would probably make a lot of y'all happier. So Square root of 3 over 3, well, that's going to be a 30-degree angle, and that's in that range, or that domain. So that'd be 30 degrees. And then what's the tangent of 30 degrees? Well, tangent of 30 degrees is square root of 3 over 3. All right, remember that false sense of security? It kind of looks like it's just canceling out. So let's see, our cosine of cosine 3 pi over 2. All right, same logic. Cosine 3 pi over 2. All right, well, that's down here. And cosine value of that would be 0, that's the x. So now I need arc cosine of 0. All right, well, arc cosine is going to be from 0 to pi. So if we think about a unit circle, where is cosine 0 again in that range? Well, that's going to be at pi over 2. Not the same thing as what you started with. And the problem is that angle right there is outside the acceptable domain for arc cosine. So that's where we run into an issue. If the angle you're given here, I'm going to make it formal in a second, but basically if the angle you're given is from 0 to pi, you can just nullify all this and that's your answer. If it's outside that span from 0 to pi, we got to be a little more careful and kind of go through this process. So this is the fallback. You can always work the whole process. You'll be safe. If you can remember the intervals and kind of think about it that way, then you can go that route. Now, here's the formal definitions, the properties is the way the book lists it. So these two scenarios, sine of arc sine and arc sine of sine. So that sine of arc sine, it's that function composition idea. You can just nullify those and end up with x. And you can do that, nullify and end up with y if these conditions are met. So it's really just the normal domain and range for the arc sine function. Remember, domain for arc sine, since it's an inverse, is your trig ratios. The range is the angle. So be a little careful how you answer this, because you take arc sine of a ratio. Maybe easier to think about what you started with. You take sine of an angle. So in this case, these y values are angles. So negative pi over 2 to positive pi over 2. And again, you take arc sine of a ratio, so the x values are your ratio. And if you look at how arc sine, the function's laid out, the x-axis was your ratios, the y-axis was your angles, or your angle values. Okay, pretty similar statement here. It's just saying that we can nullify these only in these conditions. So again, you take arc cosine of a ratio. So arc cosine goes from -1 to 1. And the angles that you use end up being from 0 to pi. And then same thing for tangent, arctangent. So you take arctangent of a ratio. Now tangent, there's no limit to how the ratios go. I mean, it may make more sense to go back to the normal tangent function. If you think about the ratios on a tangent function, there's no limit to what you end up with because you get those asymptotes. So that's negative infinity to infinity. So if you're looking for some kind of hard, fast rule, it always works with tangent no matter what. If you do tangent, arctangent, at least in that order. Now, if you're doing tangent of the angle in here, well, it only works from negative pi over 2 to positive pi over 2. So probably safer to do the tests like I did on all three of those other examples. But, I mean, these are the conditions. The main thing I really need you to remember, make sure you know the angle intervals that these arc functions work for. Sine and tangent, negative pi over 2 to pi over 2. Cosine exists from 0 to pi. That's really the key things you've got to remember.